Are you still deploying Azure databases manually through the portal? It's time to skip the digital order forms and master infrastructure as code, IAC, to build faster and more consistently. In this course, we move beyond the Azure portal to show you how professional cloud deployments work. We will explore how the Azure Resource Manager ARM coordinates building services, and how you can use tools like GitHub and Visual Studio Code to manage your infrastructure scripts. You'll learn how to replace error-prone manual clicks with clean Bicep code and automated PowerShell scripts, giving you complete control over your cloud environment. The Azure portal looks like a massive control room and is a fantastic visual learning tool. But in reality, it is just a digital middleman translating your form entries into background commands. To operate like a true cloud professional, we skip the portal and use infrastructure as code. By writing simple text scripts to describe our environments, Azure builds everything automatically. This unlocks perfect consistency, lightning-fast speed, and seamless DevOps teamwork. Imagine Azure as a sprawling city. Every request you make, whether by portal, code, or script, goes straight to the conductor Azure Resource Manager, who acts as city planner and mayor combined. ARM is the brain, coordinating hundreds of specialized departments known as resource providers, like compute, storage, and network. These specialists must cooperate. For instance, the SQL provider acts as a general contractor, calling on the storage provider to reserve space for your database and backups. While you see a shiny new database, underneath, it's just a transparent assembly of those same fundamental cloud blocks you can control directly. To embrace infrastructure as code, we must trade our physical screwdrivers for a digital toolbox. First, we need a library to store and share our work. That's GitHub, the world's standard code repository, filled with templates and examples to jumpstart your projects. Next, we need a modern workbench to actually write that code. Enter Visual Studio Code. It's a fast, lightweight editor that color codes your text, catches errors instantly, and links seamlessly right back to GitHub. Now that we have our digital toolbox, how do we actually speak to Azure? You have a few options. The raw, native language is the ARM template. It is incredibly precise, but very dense and complex. For a human-friendly alternative, Microsoft created Bicep. It is a declarative language that lets you describe your final result in just a few clean lines. Finally, when you need to run sequential, step-by-step actions, you can use foundational scripting languages like PowerShell or the Azure CLI. Once your code is deployed, the operational phase begins. You might wonder why Azure doesn't automatically scale your databases to save money. Because scaling alters your invoice, Microsoft leaves that power in your hands. You build the schedule. As you launch, remember that billing only starts when resources are fully online. If a silent, automated deployment fails, the Azure Activity Log will reveal the exact error. Finally, don't rely on risky internet scripts. Always use Azure Verified modules for secure Microsoft-approved building blocks. We began our journey by moving beyond the Azure portal, realizing it was just a visual middleman. We embraced infrastructure as code to bypass manual clicks and guarantee perfect consistency for our deployments. We learned that the Azure Resource Manager acted as the central brain of the operation, coordinating specialized resource providers to build our cloud services. To write and manage this code, we put away our physical tools and adopted GitHub as our cloud library and Visual Studio Code as our modern workbench. Finally, we mastered the cloud's languages, scheduled our own custom autoscaling, troubleshot silent deployments using activity logs, and secured our infrastructure by relying on fully tested Azure Verified modules.